A cannon is fired horizontally with a velocity of 50 meters per second from the top of a cliff 90 meters high. After how many seconds will it strike the plane at the foot of the cliff? At what distance from the foot of the cliff will it strike the ground? With what velocity will it strike the ground? A cannon, let's say, is fired horizontally with a velocity of 50 meters per second from the top of a cliff 90 meters high. Now, this velocity of projection has nothing to do with the time taken for the cannonball to hit the ground. Look at it. This is the cliff, the platform. Then you have a cannon on top. You project it with a velocity. Before this thing will come to the ground, it has to go to the edge of the cliff. And when something is falling from this side down, it's independent of the velocity of projection. The time starts counting only when it starts coming down from this point here down. And that time taken does not depend on this velocity of projection. So we take initial velocity as zero because this object is now being released from this height, which is independent of this velocity of projection. So u is equal to zero. Then it's under the influence of gravity, of course, and it's coming down. So gravity is positive, 10 meters per second square. And the question says, after how many seconds we are looking for time t, we don't know. The height of the cliff is given, which is 90. The distance is 90 meters. So this thing start falling from a height that is equal to the height of the cliff. Okay. So now, which equation contain u, g, e, and s? That is s equal to ut plus half gt squared. And u is zero, so the whole of this is zero. So 90 equal to half times 10 times t squared. 90 equal to 5t squared. 2 here 1, 2 here 5. So dividing both sides by 5, t squared is equal to 90 divided by 5, 18. The t squared is 18, which means t is square root of 18. And what is square root of 18? 4.24. So the time taken is 4.24 seconds. That is question 1. Then question 2, manage here. You say at what distance from the foot of the cliff will it strike the ground? Now, let me draw something to drive my point home. This is our cliff, and even this thing is just released from the height of the cliff down. It will likely land on the foot, at the foot rather, at the foot of the cliff. It landed away from the foot of the cliff because of this initial velocity of projection. As this thing is projected with 50 meters per second, it's going to describe a parabolic path like this and then land here. And which means this horizontal distance from the foot of the cliff depend on this initial velocity of projection. So u there, 50 meters per second. However, the horizontal component of motion does not depend on gravity. So g is zero. Then what else do we need? We need the time taken for the ball to fall from that height. And the time taken, we just calculated it to be 4.24. So t is 4.24 seconds. So using this same equation, s equal to ut plus half gt squared. So in this case, g is zero. So this term of the equation is zero. S therefore is 50, the initial velocity of projection times the time taken, 4.24. 4.24 times 50, that is 212.1, 212.1 meter. Then question 3, with what velocity will it strike the ground? With what velocity will it strike the ground? The thing is released from a height, so initial velocity is zero. So under the influence of gravity, g is 10, and it's coming down from a height of 90 meters, and the time taken is 4.24 seconds. And we are to find v. So any equation that contains v should be able to give us that. Let's use the first one. U plus gt. U is 0. The g is 10. 10 times 4.24, which is 42.4 meter per second. Now, if you use any other equation, you see that you arrive at the same thing. Let's try the third one, which also contains v, because the second one does not contain v. The third one says v squared equal to u squared plus 2gs. LV, V is 0, so we concentrate on 2gs. 2 times 10 times S is 90 times 90. 2 times 10 is 20. 20 times 90, that should be 1,800. And square root of 1,800, because this is b squared. Square root of 1,800. Here we have the same thing, 42.4 meter per second.